So you already studied all these things, so please let us speed up. You write along with me, okay? Don't wait until I finish it. Now, parallel combination of please write down resistors. What is parallel combination? Voltage must be same. And obviously current divides. Current divides. Okay, in case of series combination, current is same. But remember, the voltage will automatically divide. When current is same, then only it is series combination. Okay, if voltage divides, but current is not same, that is not a series combination. And wherever current is same, there definitely voltage divides. But wherever voltage divides, the current may not be same. So please try to understand this fact. Okay, so what is series combination? Current is same. By default, voltage gets divided. The second statement need not to give it separately. Similarly, for parallel combination, voltage is same. Need not to mention this because current will automatically divide for a parallel combination. There is no need to give specifically this particular statement. But remember, wherever voltage is same, the current divides. But wherever current divides, okay, the voltage may not be same. So be careful in that. Okay. So what is parallel combination? Voltage same. That's it. Because current divides, it does not mean that they are in parallel. Voltage same. If voltage is same, then only it is parallel. If current is same, then only it is series. Okay. Well, now coming to this now, I'm giving you the two resistors connected in series. And this is G1 and this is G2. And you know that conductance is nothing but the reciprocal of resistance. Say this is some current I. Then what will happen if the total voltage is, let us say, V across the source, then voltage across this particular source is also V, and the voltage across this particular element is V, and the voltage across this particular element is also V. And current gets divided here, I1 and this is I2. Let us say this is A and B. Okay. So why voltage same? Because to satisfy KVL, plus V and minus V. Plus V and minus V. Voltage 0. Plus V and minus V. This loop also. Every loop KVL must be satisfied. And look at this node, the current I and I1 and I2 gets divided. Algebraic sum of the currents at this node must be 0. Algebraic sum of the currents at this node must be 0. So current divides to satisfy KCL. Voltage is maintained same to satisfy KVL. That's it. Now let us look at GAB. What is GAB here? When n number of elements are connected in parallel, GI. And effective conductance, remember, it will increase. And it is greater than even the highest value of G1, G2 and so on, Gn. What about the resistance then? Reciprocal of conductance, right? So 1 by RAB and 1 by Ri, but I want RAB, therefore I is equal to 1 to N, 1 by Ri. Therefore, you know that the effective resistance will decrease. That is less than even the lowest value of, okay, even the lowest value of the resistors. Please write down along with me, okay? Please write down along with me, okay? You can note down the things along with me. N is equal to 2. You remember generally the formulas. GAB is equal to G1 plus G2. RAB is equal to R1 R2 by R1 plus R2. Okay. Let us apply Ohm's law to the individual elements. I1 is equal to V into G1. I2 is equal to V into G2. From this, we understand that I is directly proportional to G. and inversely proportional to R. But we also know that the current gets divided. How it is getting divided? It is getting divided in proportional to the conductance of that particular element. Therefore, from this we can understand, okay, I1 is equal to G1 by G1 plus G2 into I. I2 is equal to G2 by G1 plus G2 into I. This is current division rule. Current division rule. The same current division rule we can apply in terms of even resistance. That is, I1 is equal to 1 by R1, 1 by R1, 1 by R2. That is, finally, you simplify that, you get R1 plus R2, R2 by R1 plus R2 into I. And I2 is equal to R1 by R1 plus R2 into I. This is a formula for current division when elements are connected in parallel in terms of conductance, in terms of resistance. But I would like to take when there are n number of elements, then what is the current through the kth element? Okay, I1, G1, IK, GK, right? Therefore, GK by summation I is equal to 1 to n GI into I. The same thing can be written in terms of resistance 1 by RK by summation I is equal to 1 to n 1 by Ri to I. This is the expression for current through kth element when n number of elements are connected in parallel. Note down all of you. Don't take much time because you already know. You write please along with me. Current through Now let us look at the problems. Okay, we start with a simple problem. All of you can easily answer it. Let us try to find the resistance across AB terminals. 3 ohm and say this is 7 ohm. Or else, yeah, 40 ohm and 10 ohm. What is RAB? Okay, what is RAB? You can find it. You can start working on that. Okay, what is RAB? How the elements are connected. First, we need to identify. To find RAB, first we need to identify what? How the elements are connected. If I ask you 10 and 40, how they are connected? Series or parallel? Okay, let's see. Let's come back again. How these two elements are connected, 40 and 3? How they are connected? Series? Parallel? We'll come back to that again. How 40 and 7 are connected? How 3 and 7 connected? I think most of you can easily answer 3 and 7 how they are connected. No doubt they are in series. But how about this 10 and 40? Are they in series? No. Are they in parallel? No. Neither series nor parallel. 40 and 3? Neither series nor parallel. 40 and 7? Neither series nor parallel. 7 and 3, 3 and 7, they are in series. That's it. How? Let's connect one source. Across the terminals where the resistance is required, assume that some current is delivered, I. What is the series combination? The two elements are said to be in series if current is same. Yes or no? If voltage divides, they are in series, or current is same, then only they are in series. Which one is correct? When current is same, then only they are in series. If voltage divides, does not mean that they are in series, because I told you clearly that wherever current is same, the voltage gets divided. But wherever voltage is divided, the current may not be same. It's the best example to understand. This voltage V gets divided here, plus minus V1 and plus minus V2. The voltage gets divided. Why voltage divides here? Because to satisfy KVL. But what is happening to the current here? Here it is I, but here is I1 and this is I2. So current through 10 is I, current through 40 is I1. The current is not same, but once you apply the voltage gets divided here. What's happening here? Current is not same and voltage is not same. Current is same. When current is not same, they are not in series. When voltage is not same, they are not in parallel. Neither series nor parallel. I hope you understand the point. Coming to now, these two. Sir, when we are sending current I, it is getting divided. Can't we take them in parallel? Now you tell me. If current divides, is it parallel combination, or if voltage is maintained same, parallel combination? Current divides does not mean that they are in parallel. Wherever current divides, their voltage may not be same. But wherever voltage is same, the current will definitely divide. Look at this. How these two elements are connected. Now this voltage can be divided into further V3 and V4. Can you agree with me, all of you? Because to satisfy KVL. To satisfy the KVL in this loop, certainly this V2 must be divided into V3 and V4 to satisfy KVL. Now what is the voltage between these two? I mean, what is the voltage across this element V2? What is the voltage across this element V3? The voltage is not same. They are not in parallel. They are not in parallel. The voltage is not same. They are not in parallel. Yes or no? Sir, current divides here. Current divides here. Why can't it be parallel? No, they are not in parallel. Current divides does not mean that they are in parallel. Voltage is same, then only they are in parallel. Clear, all of you. But look at these two elements. The current is same and voltage gets divided. See, wherever current is same, the voltage divides. Wherever voltage divides, the current may not be same. It's very, very clear, right? Now let us not get any doubts in this concept again, because further we need to accelerate. Whenever the problem is given, whenever a complex network is given, within no time, you must be in a position to identify whether the given elements are in series or parallel. So you have series combination or parallel combination, or else sometimes neither series nor parallel. Neither series nor parallel can be same as what? No relation. That's it. Okay? That is why we always come from the rightmost side to find the resistance on the leftmost side. Opposite direction always. Whenever we want rightmost side the resistance, we start from the leftmost side. Whenever we want the resistance in the middle, we come from both sides. We always move in opposite direction to determine the equivalent resistance for a reason to identify the series and parallel combination. Otherwise, it is not possible to simplify the network. Okay, so look at this now. We come from the rightmost. 3 and 7 are in series with respect to these 2 points. So 3 plus 7. And this result is parallel to 40 with respect to these 2 points. Parallel to 40. And this result is in series with this 10 with respect to AB terminals. Plus 10. That's it. This is what? RAB. Total resistance or input resistance, both are same. Now 3 plus 7, 10, 10 into 40 by, okay, 10 plus 40 plus 10. What is this 400 by 50? 8 plus 10. What is the answer? 18 ohm. Hope you understand this, all of you. Now whenever a network is given, you should not get confused. In no time you must be in a position to identify whether the given 2 elements are in series or parallel. So I cannot elaborate all the time like this. I explain in detail so that any layman can understand. Okay. Now I give you a group of problems. You can solve one after other. I give you. I think all of you noted down this, right? Okay. Find RAB. You solve this. Meanwhile, I am noting down another problem. Then I will come back to explain that. Okay. Please solve it. So this is only an example. Now what you do is you can refer your workbook. Okay, classroom workbook you can see. Question number 1 we have already dealt with. And then 2, 3, 4. Okay. You can open the chapter 1 DC circuits classroom workbook. You can open that. For all these questions, for all these diagrams, the question is simple, that find RAB. So the 4 questions given, first question we have already solved. Okay. Now look at this, how the elements are connected. How these 2 elements are connected. How 3 and 6 are connected. I think 3 and 6 are neither series nor parallel. Yes or no? Because if current is sent, definitely looks like current is getting divided, therefore they are in parallel. But I told you, current divides does not mean that they are in parallel. Parallel combination means voltage must be same. If voltage across 6 ohm and voltage across 3 ohm is same, they are in parallel. Okay, therefore You look at this, now these two are neither series nor parallel. These two are also neither series nor parallel. But I can say these two are in series, and these two are series. Then the resultant here and the resultant here both are in parallel. So 3 plus 2 parallel with 6 plus 4. What is this now? 5 parallel 10. Okay. What's the answer here? 5 into 10 by 5 plus 10. 5 3 10 by 3 ohm. 10 by 3 ohm or 3.333 ohm. Okay? Right. Now third one here, third question you can see how the elements are connected here. 3 and 2 are in series, 6 and 4 are in series, no doubt. But what is this value 0 ohm? Yes or no, short circuit or zero resistance path you can say. This is 10 ohm, this is 5 ohm, this is 0 ohm, but all these elements are connected in parallel. Yes or no? N number of elements are in parallel, one among them is 0, then the total value is 0. The RAB will be 0. That's it. Clear all of you? RAB is 0. That's it. You can also remember like this. This may help you a lot in future when you deal with certain problems. Sometimes you can remember certain things which are very important. Look at this. You are finding the resistance across AB terminals. AB terminals can be treated as input terminals. Nothing wrong in that. Okay, if you treat AB terminals as input terminals are shorted. That's it. Input terminals are shorted, then the resistance is 0. That's it. The total resistance is 0. There is no need to calculate, no need to simplify the network. Simply you can put it 0. Input terminals are shorted. That's it. Understand all of you? Now, coming to this. Coming to the fourth one. In the fourth problem, look at this. There is a zero resistance path, but that is not connected between input terminals. Yes or no? Some other terminals, we do not know. Some other terminals actually. The input terminals are not shorted. Some other terminals are shorted here. Getting? Then how do you solve it? Can I redraw the network something like this? This A is taken out, B is taken out, and these two terminals are shorted. That means both terminals are operating at same potentials. There is no potential difference at all. When two terminals are connected through a zero resistance wire, both the terminals are operating at same potential. That means there is no potential difference. I can join them and make it as a single point. There is no problem at all. So remember, this A is taken out. Okay, this A is taken out. And at A, what are the elements connected? 3 and 6. This A is taken out. This is A. And this is B. Okay, this is B. But what are the elements connected here at B? 2 and 4. Okay, 2 and 4. 2 and 4. But now, this point and these points are connected here. That's it. This is what I made it a single point. Those 2 points are connected here. Okay, so 3 and 6, 2 and 4. These two are in parallel. These two are in parallel. Then the resultant 2 elements are in series. That is 3 parallel 6 plus 2 parallel 4. That's it. Yes or no? Then what do you get? 3 into 6 by 3 plus 6 plus 2 into 4 by 2 plus 4. Finally, you can check with the answer. You get 10 by 3 ohm. Nothing but again 3.333 ohm. Okay. So this is how you need to answer. You need to simplify the network. The simple networks You cannot expect this level in the exam, but just for practice I'm giving you, okay? Now see, what is the thing that we have done here? Since there is a zero resistance path between these 2 points, I can say these 2 points are operating at same potentials. That means there is no potential difference at all. I can join these 2 points. I just joined here. Look at this. And this terminal is taken out. And 3 and 6 are joined here. 2 and 4 are also joined here. That's it. After joining, it looks very simple that these 2 are in parallel, these 2 are in parallel, then the resultant is in series. Understand? Okay. This is how you need to simplify. And then next, we'll go for 5th one. First, you quickly note down this. Then we can go for 5th one. All of you note down that 5th question also. Now let's go with the 5th question here. 5th question. Remember, one must be expertise in reducing the network. Equivalent resistance calculations, one must be really expertise. I'm telling you, otherwise you won't really enjoy the network analysis later on. You should smash a network. Once you come across, you should smash. You can easily solve. You must be in a position to solve it. Look at this example. So one another simple one, but look at this. Can I redraw this network? Something like this. This is A. This is B. Look at this element is connected between these 2 points, right? So therefore, that's it. 3 ohm, 2 ohm, 10 ohm, 4 ohm, 6 ohm. Now look at this. How the elements are connected? 3 and 2, neither series nor parallel. 3 and 6, neither series nor parallel. Don't say parallel. It's not possible. The voltage across this may not be same as voltage across this. Physically, when you see it, forget about the values. But physically, when you consider the network, the elements neither series nor parallel, neither series nor parallel, neither series nor parallel. You take any 2 elements in this particular network, they are neither series nor parallel. Yes or no, all of you? How do you solve it? When all elements are neither series nor parallel, how do you solve it? Usually, when all elements are neither series nor parallel, usually there is an approach called star delta transformation. This is a standard procedure. Okay, when all elements are found to be neither series nor parallel in the given network, you must solve using star delta transformation. But this problem doesn't require star delta transformation. If you closely observe, this is forming a bridge. And it is a balanced Wheatstone bridge. It's a Wheatstone bridge. And that too, this is a balanced Wheatstone bridge. 3 by 2 is equal to 6 by 4. Or else 3 by 6 is equal to 2 by 4. It is a balanced Wheatstone bridge. Under balanced condition, what is the current flowing through 20 ohm? 0. Yes or no? Therefore, look at this. For this problem, star delta transformation is not required. 3 by 6 is equal to 2 by 4. It is a balanced Wheatstone bridge. Under balanced condition, current flowing through 10 ohm, current flowing through 10 ohm is 0. Current through 10 ohm 0. You connect an ammeter here, it deflects to null in series with the 10 ohm. Current 0 refers to what? Current 0 refers to what? Open circuit. Then RAB is equal to, when it is acting like open circuit, how these 2 elements are connected in series. We have seen already in the second problem. 3 plus 2, because it is open now, current 0 refers to what? Open. Voltage 0 refers to what? Short. Okay. So 3 plus 2 parallel with 6 plus 4, it is 10 by 3 ohm. Now, coming to this, another one. Even if you connect the voltmeter across these two terminals, the voltmeter deflects to null. See, under balance condition, you connect an ammeter in series with 10 ohm and you connect voltmeter across this 10 ohm. Both that ammeter and voltmeter will deflect to null. That means what? Voltage is 0. Voltage 0 refers to what? Voltage 0 refers to what? Voltage across 10 ohm is also 0. Voltage 0 refers to what? Short circuit. Then tell me here. Short circuit. Then if it is short circuit, it's simply like your third case. When it is acting like a short circuit, this point and this point look like at same potentials. In such case, when you join the 2 points, just like in the third example, third problem we have seen, 3 and 6 are connected in parallel. 2 and 4 are connected in parallel, and then they are connected in series. Then 3 parallel 6, 2 parallel 4, yes or no? Plus, that's it. So 3 parallel 6, 2 parallel 4, then this is going to be what? 10 by 3 ohm. You get the same answer. So, since it is a balanced Whitson bridge, under balance condition, you can take either current 0 condition or voltage 0 condition. You will definitely get the same answer. Do not worry about that. Understand all of you, okay? Suppose if the given network is not a balanced one, what will you do then? You have to go for standard transformation. If I replace this 2 ohm by 2.1 ohm, it becomes unbalanced. Yes or no? Then what is the approach that to solve this particular network? Under unbalanced case, you have to go for standard transformation. We are going to discuss that standard transformation in the next upcoming sessions. So please note down this quickly. Meanwhile, I just note down another problem. Okay, please note down this. Current 0, voltage is also 0. Current 0 condition you can apply, or voltage 0 condition you can apply. Current 0 refers to open circuit, voltage 0 refers to short circuit. Find RAB. Find RAB. Look at this particular problem, all of you. I will also note another problem here. Sixth problem. Look at this. How the elements are connected here. How 2, 12, neither series nor parallel. How 2 and 20, neither series nor parallel. How 12 and 4, parallel combination. Yes or no? Okay, so 12 and 4 and parallel. Sir, how it is parallel? This point and this point both are operating in same potentials. You can take this and connect here. It does not make any difference. Yes or no? Therefore, how these two elements are connected? If you apply some 10 volts here, the same 10 volts is appearing across these two terminals or not, because this point and this point both are operating at same potentials. Understand all of you? Okay. So these two are in parallel. 12 parallel 4. This is, you can work out 3, because 12 into 4 by 12 plus 4. That's it. Now, what about this 20 ohm? This is 2 ohm. How these two are connected? Series, right? Now, that result is parallel to 20. Therefore, 2 plus 3 parallel with 20. What is that RAB? 5 parallel 20. 5 into 20 by 5 plus 20. 100 by 25. This is 4 ohm. 4 ohm. Okay. Let's go for that problem quickly, all of you. Note down this. Meanwhile, I'll just note down another problem here. What about this? Look at this. How the elements are connected. How 9 and 3 are connected. Neither series nor parallel, because there is an element. You cannot see the volt across 3 and volt across 9. Both are same. You cannot say because there is an element 25. How these two are connected? Neither series nor parallel. If you cut down this, they are in series. But there is a connection. You cannot say they are in series. How these two? Neither series nor parallel. You can observe that all elements are neither series nor parallel. Okay? When all elements are neither series nor parallel, usually you have to go for standard transformation. But this problem doesn't require. If you closely observe, it is forming a bridge. Okay, the bridge models are very simple. There are 2-3 types. You can easily identify. The first one is a standard model. The second one is this. You can see. And third one I'm going to explain you again. Now look at this. Can I redraw the network to understand that there is a bridge? Okay, once you understand, you cannot redraw in the exam because you have to save the time. This is A, this is B. At A, what are the elements connected? 5 and 15. This is 5. This is 15. At B, what are the elements connected? 3 and 9. But 3 is connected to 5. 9 is connected to 15. Yes or no? 9 is connected to 15 here. Okay. And look at this. This is the point where 3 and 5 are connected. This is 1. This is the one, right? And this is the point where 15 and 9 connected. I think this is the one. Between these 2 points, what is connected here? 25. Okay. Now you are looking for the resistance across AB terminals. Yes, sir. Now, how the elements are connected? I told you already that they are all neither series nor parallel. Now it is forming a bridge. Only thing you have to check whether it is a balanced bridge or not. Yes. 3 by 9 is same as 5 by 15. So it is a balanced bridge. Under balanced condition, you can go with current zero condition or voltage zero condition. Current zero refers to what? Open circuit. For open circuit, if current through not 10 ohm, it is 25 ohm. Okay, it is 25 ohm. Current through 25 ohm is 0. Current through 25 is 0 refers to open circuit. Current zero refers to open circuit. Once it is open circuit, then 5 and 3 are in series and 15 and 9 are in series. then the result is in parallel. Therefore 8 parallel 24, 8 into 24 by 8 plus 24, just 8, 32, this is right. 8 4 ja, 4 6 ja. Your answer is what? 6 4. You understand? Quickly note down. So the bridge you must identify easily. By looking at that network, you must realize there is a bridge. Bridges are standard models. Okay, you can easily identify. Please do that quickly. Do that quickly, all of you. Quickly note down. Hope you have done with this, right? Now go with that other problem, okay? Note down that. Look at the network, how the elements are connected. First, you need to identify that with respect to AB terminals. With respect to AB terminals, how the entire network is connected and how the elements are connected. Okay? I think all of it done with this, right? Okay? So please note the other circuit. Look at this network, how the elements are connected. 2 and 8, I can confidently say that they are in series. If I keep this entire part in a box. 2, box and 8, how they are connected? They are in series. But that box need to be simplified. It looks like there is a short circuit. But that short circuit is not across 9. If that short circuit is across 9, if this short circuit is across 9, then that 0 into 9 by 0 plus 9, yes or no? That becomes 0. If that short circuit is across 9, this will be 0. Then 18 and 6 will be in series because you are placing here, right? You are placing here. When you are placing here, if you place here, these two are parallel. This is 0. Even if you send some current, entire current will pass through this. The current will choose the least resistance path. But remember, this statement is valid only when that 0 resistance path is placed across the resistor. Across the resistor. It should be like this. Understand? It should be like this. When you have R and 0 ohm, when entire current, what are the current you send, that entire current passes through at 0. But now the scenario is different. The given scenario is something like this. You cannot expect the same current flows through this now. Understand? If this same connection is connected here, entire current passes through the short circuit and the current through this 9 ohm will be 0, you can neglect that element. But now the scenario is different. So in such cases, generally when you have such cases, you must deal with a simple mechanism that, numbering technique. You can see this. This point and this point both are operating at what? Same potentials. If I call this is 1, this is also 1. This point and this point both are operating at same potentials. If I say this is 2, this is also 2. Yes or no? Now look at this. This element is between 1 and 2. This element is between 1 and 2. This element is also between 1 and 2. All elements are sharing common pair of nodes. All elements are sharing common pair of nodes. What does it mean? When all elements are sharing common pair of nodes, all these elements are said to be in parallel. R1 between AB, R2 between AB, R3 is between AB. All elements are sharing common pair of nodes. That means all elements are said to be in parallel. Yes or no? Therefore, you can read rough for the confirmation 1 and 2, between 1 and 2, between 1 and 2, between 1 and 2. Look at this. This is 9, this is 18, this is 6. And between A and 1, what is connected here? 2. Okay. Between B and 2, what is connected here? 8. How these elements are connected? Parallel, simple. And that result is in series with 2 and 8. Hope you understand this. Okay. Therefore, this RAB will be now 9 parallel, 18 parallel, 6 plus 2 plus 8. These two, if you simplify, 9 into 18 by 9 plus 18. Again parallel with what? 6 plus 8. 2 plus, this is 6, parallel 6 plus 8. 6 parallel 6 is 3. 2 plus 8, 10, 13 ohm is an answer. You understand? This is how you need to deal with the problem. Most of the people may do the mistake here. Since it is 0, therefore cancel. Since it is 0, therefore cancel. 2 and 8 are in series, therefore the answer is 10. There are certain people who answer like that. That answer might be correct when the combination is something like this, connection is something like this. If this is the connection, your answer 10 ohm is correct. But now the connection is given like this, therefore that explanation or that particular approach is not correct. You have to understand this. So use the numbering technique. What is the numbering technique actually you are applying here? When there is a 0 essence where you call this is 1, this is going to be 1, this is 2, this is going to be 2. That's it. Okay, then you redraw the network. Once you get experience, there is no need to redraw the network. Okay, so this is how you can simplify, and the answer is 13 ohm. And we stop the session here. In the next session, we'll see some more problems. We actually stopped at the 8th problem. We continue with the 9th problem. There are around 20 problems in this network reduction, and we'll discuss in the next session. Okay, see you.